Here we're asked to find the currents I-10 and I-60. And what you'll notice is that this circuit is not a single loop circuit, nor is it a single node pair. It actually has a node here and a node here, right? I mean, actually this is all the same. That's all the same node. Of course, we have a ground node down here, right? But we're always solving for n-1 nodes. So there are 3 nodes in this circuit. We haven't learned any formal techniques for solving multiple nodes in a circuit, but fortunately we can do a simple circuit reduction here to find the current I-10, and then we'll do a trick to find I-60. So the thing to recognize here is that can I do anything to reduce this to either a single node pair or to reduce it to single loop? And it's quite easy to reduce this to single loop if we just consider that these 2 resistors are in parallel. So I could replace it by some equivalent resistance that would be 20 ohms in parallel with 60 ohms. This is means parallel, shorthand for parallel. Excuse me. So how do we calculate the parallel resistance? Well, it's R1 times R2 divided by R1 plus R2. So this would be 12 over 8, which would be 3 halves. Oh wait, there's a 0 there. 15 ohms. Okay? So now we can redraw this as a single loop circuit. This is 15 ohms. This is 10 ohms. And here is I-10. Now we cannot designate I-60 because it's buried inside the 15 ohms. However, we can find I-10. So here, I-10 is easily solved for. Basically, I can reduce this, and we could write a KVL equation, but it's even simpler just to note this is 10 plus 15 ohms, or 25 ohms. And so the current I-10 that's flowing here is simply the total voltage across the combined resistance divided by the combined resistance. So that's 2/5 of an amp, or 0.4 amps. All right. Now, to find I-60, I-60 is equal to the voltage across the resistor, V60, but divided by 60. Of course, V60 is the same voltage as V1. You see that? Because V1, it's actually V1 minus the ground node, which is 0 volts. So we didn't really have to label V60. We could have just said V1. So can we find V1? Well, we can. We can do KVL around here where we would say minus 10 volts plus I-10 times 10 ohms plus V1 is all equal to 0. Could do that. But I can even write this, and that's correct. But sometimes you don't even need to write the KVL equation. We can just think of, all right, I'm supplying 10 volts from the left, and as that 10 volts or any charge is delivered from the left over to this node here, it drops. I lose some voltage across this 10 ohm resistance. So V1 or V60 is 10 volts minus whatever I drop across the 10 ohm resistor, which is going to be equal to 0.4 amps times 10, or 4 volts. Now we would have found the same thing if we had solved for this KVL. All right. So V1 is 60, therefore I60 is 6 volts divided by 60 ohms, or 0.1 amps. So we have solved for I-10 and I-60.